This is the fourth of 7 videos on index notation and index laws. This is introducing to you the 6th index law, which is a completely new law. Our learning goal today is to continue with our knowledge of index laws to simplify and solve different problems. So let's see what we're going to do here. We're going to look at negative indexes. That is, the power is not a positive integer, it is a negative integer. So, as we saw with the third index law, let's look at what happens as we move up a power or an index, adding 1 to each of those, we're multiplying by another 10. And so our numbers increase, the number of zeros in the digit in the number by moving the decimal place to the right, 1 place value. If you go the other way, so that's moving up. If you go the other way, we're dividing. We saw that with the third index law, or the zero law. We're subtracting 1 from the index, and we divide by 10. Now moving down, one more line, we subtract 1, and that gets us to 10 to the negative 1. We're dividing by 10 there. That's what we did here. We divided by 10, divided by 10, continue the pattern. So what that gives us is the result is 1/10 or 0.1. If we were to continue that pattern, it would be 1 over 100, which is 1 over 10 squared. So this is what the index law looks like. Okay, so here's our index law. We've got 2 cubed divided by 2 to the power of 4. So it's a different base this time, but the same rule applies. So 2 to the power of 3 take 4, because when you divide bases that are the same, you subtract the indices. So 3 take 4 is negative 1. So there's our negative index. What does that look like? So let's look at this. If we expand those using numbers, 2 cubed is 2 times 2 times 2 is 8. 2 to the power of 4 in a similar fashion is 16. 8 over 16 is the same as 1/2. So what we see here is that 2 to the negative 1 is the same as 1/2. So what happens is, with the negative index law, whatever is there, we invert to the denominator. So that's actually 2 to the power of a positive 1 on the denominator. So there's our 1 there. Remember, if there's no power, it means the index of 1. The ramification of that is, if that was 2 to the negative 2, this would be 1 over 2 to the positive 2. So the effect of the negative index is to invert the number. So that base goes to the denominator, or if the negative number is at the bottom, like this, 2 to the negative 2, we'd invert that back to the top. It becomes 2 squared, which is 4. So that's what happens with negative powers. So let's look at this a bit further. There's the law. A to the negative 1 equals 1 over A. The negative power inverts to the bottom, as we saw before with the power of 2. If the power is a bigger number, the whole power goes to the bottom and becomes positive. And vice versa. If the negative index is on the bottom, we can move to the numerator by changing the sign from negative to positive. So here's an example. A to the 5 divided by A to the 7. So we can use the second index law here, because we're dividing the A base as the common base. So it becomes 5 take 7. There we are. That gives us A to the negative 2. Now, using the fifth law, we write it with a positive index by inverting that to the denominator and making it positive. Now, it's preferable to use positive indexes because it allows us to manipulate the algebraic expressions a bit more easily. Here's another example. This one's more complex. It's actually using most of the index laws now. So we've got our fifth law here, which involves the power to a power law. So we need to split up this bracket here and put everything to the cubed power first. So we evaluate the numerator first. So 2 to the power of 3, m squared to the power of 3, y to the 4 to the power of 3. And that equals 2 cubed is 8. We multiply the indexes there, 2 times 3 because of the fourth law, and 4 times 3 here for the fourth law as well. We haven't touched the denominator just yet. Wait till we finish the numerator. So if we evaluate that, we get 8m to the 6, because 2 times 3 is 6, 4 times 3 is 12, so we get y to the 12. And now we can divide using the second law. So 8 divided by 3, leave that as a fraction. You can't evaluate that as a nice neat decimal. It's going to be 2 2/3, or 2.6 recurring. Neither of those really work very well. They're not overly useful to us. So we leave that alone. So we've got our m's, 6 take 8, because we're dividing the same base. And here for y, 12 take 3. We end up with 8/3, 8 over 3 still, we haven't touched it. 6 take 8 is -2 for the m base. And for the base of y, we're left with an index of 9. 12 take 3 is 9. Now, as we said before, we prefer positive indexes, so we're going to move that negative, get rid of the negative, by inverting that or flipping that to the denominator. So we end up with 8y to the 9 over 3m squared, and that's the preferable way of writing it. Some of you may wish to write that 8/3 separately, that's fine, but you'll notice this is the way we tend to see it in the textbooks and other places. So that's what we've done, we've flipped that to the denominator. So that's the end of that lesson. The negative index law, basically a negative power flips between the numerator or the denominator to make it positive. That's pretty much what you need to remember.